student, welcome back to Install video lecture series for maths. We believe in democratizing education for all. Today we are going to complete the chapter real number. Come on, let's get started. Previous video we have understood about the LCM and the HCF. Now there is a relationship between the LCM and HCF with the two numbers, okay? So that is nothing but the product of LCM and HCF is equal to the product of the two numbers, right? That is a beautiful relationship between it. Means if you find a multiplication of the two number, it is same as the HCF and LCM, okay? This is the relationship. Now let's see with one example. Now find the LCM and HCF of these two and let's check whether this is equal to the product of the two numbers. So suppose we have 18 here first. So 18 we are going to do the prime factorization. So we have 9, then we have 3 and 3. So 18 can be expressed as 2 into 3 into 3, right? And then we have next number 24. So we have 2, 12, 2, 6 and then 2, 3. Here we have 24 is equal to, right, 2 into 2 into 2 into 3. Now the rule of finding the HCF and LCM is that in HCF you will be taking out the common factor, right? So the common factor, the first prime factor which is common to both is 2. So we'll write 2. Next we have 3, right? So 3 is here and 3 is here. So we have 3. Apart from this 2, when we look at the another 3 of 18, okay? So we don't have any other 3 here. So we are not going to take this 3. Same for this 2. If you take this 2, it is not there in this. So again this is not considered. So the HCF is what? 6. Now to find the LCM, what we will be doing is we will be taking the HCF first, right? So 2 into 3. Then common factor we are taking as 1. And then what we will do? We are going to take all the factor left out, right? So here 3. Right, 2, 2. So we have 3, 2 into 2. So we have 72 as the LCM and HCF is what? 6. Now let's calculate the product of these two. So 18 into 24 and product of these two, HCF into LCM, right, which is equal to 6 into 72, right? So we have 432 here. So when we calculate this also, we will have 432. It means the product of the two number is same as the product of LCM and HCF. Okay. Now we can see one example with 3 values. For 3 values also you can find LCM and HCF. Okay, no doubt. So for this, okay, what we are going to do? We are going to find the prime factorization. Now for 2, right, so we have 6 here, 2 here, 3. So 12 we have 2 into 2 into 3. And for 30 we have 2, 15, 3, 5. So we have 30 is equal to 2 into 3 into 5. And another one we have 42. So 2, 21, 3, 7. So we have 42, 2 into 3 into 7. Now HCF common to all. So we have here 2, 2, 2. So we'll write 2 into. We have 3 here, 3, 3, 3. So 3 at 6. Now for LCM, we have 2 and 3, right? 2 into 3. We have the remaining numbers 2, 5 and 7. 2, 5 and 7. But one thing I would like to add here is that if you have 1, 2 here, okay, suppose. So 1, 2 here, then you are not going to take 2 into 2 here. You will be considering as only 1, 2. Common. Okay, that's the rule. or else you can use the long method for finding the LCM also. I'll be giving you that example also. So here we have the LCM is this. So after calculating this, we have 420. T is the LCM. Now, what I was saying is the long division method, okay, is that take all the three numbers together and find the LCM. That is here 12, 30 and 42, right? So like this, 2, 6, 15 and 21 like this. So we can take it 3, then we have 2, 5 and 7. Like this also you can calculate the LCM by multiplying all the primes here. So this is how we calculate LCM and HCF. Now let us see one more sum, that is 144 and 216. We are going to show that the LCM and the HCF multiplication is same as the product of the two number. So 144. So 2 we have 7, 2. So we have 2, 36, 2, 18, 2, 9, then 3, 3. Next we have 216. So 2, 108. So 254, 227. So 3, 9. So 3, 3. So we'll write 144 and 216. 144 is 2 into 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 3 into 3. And 216 we have 2 into 2 into 2 into 3 into 3 into 3. Now, to find the HCF, we'll be taking the commons, right? So, we have 2, 2, 2. So, 2 into 2 into 2. For 3's, we have 3 and 3. So, we have 3 into 3. So, we will be multiplying this and we have 72, right? Now, to find the LCM, we are going to write 2 into 2 into 2 into 3 into 3. Then, we have 2 and 3 extra here, so which are not common. So, we will be multiplying with that and same we will get 432. Okay. So, LCM is this and HCF is this. So, next what we are going to do? We are going to multiply LCM and HCF and we'll get one answer. Check that is equal to the product of this two numbers. Every time you will be getting the same answer. Okay. So, let's see this theorem. Let P be a prime number. If P divides A square, then P divides A, where A is a positive integer. Come on, let's see this proof. Here it is given that A is a positive integer. So we can express this as a product of prime using Fundamental Theorem of Arithmetic. So let's write the proof. So given A is a positive integer, using Fundamental Theorem of Arithmetic, so we have A is equal to P1 into P2 into P3 and Pn, where Pi's are primes. So here Pi's are not necessarily distinct. So here it means that P1 and P2 can be equal. Okay, like 6, if you take the example of 6, we can express 6 as 2 into 3, right? Or when we take 12, we have 2 into 2 into 3. So here 2 and 2 are equal. Like this, some primes may be equal. So Pi's are not necessarily distinct. So we can add here, Pi's are not necessarily distinct. So here we have A as a product of primes. So we can square this equation. So squaring on both sides, we have A square is equal to P1 into P2 and so on Pn, so square. So here when we square this, we will square P1 by using the law of indices. So P1 square into P2 square and so on, we have Pn square. So we have A square is equal to this. Now we know that P divides A square. So we have P divides A square. This means A square can be written as P into K, right? Means when a number is divided by any prime or any number, we can express that given number as a product of that divisor, as right? So we have K is any integer. So K is an integer, right? So therefore, the previous equation that we have, A square is equal to P1 square, P2 square and Pn square can be written as P into K. We can substitute the left hand side as P into K and the right hand side as it is. Therefore, P1 square into P2 square and so on, we have Pn square. Now, here we know that by using Fundamental Theorem of Arithmetic, we have a number can be expressed as a product of primes and the expression is unique, right? It means that this expression and this expression is unique. Therefore, and we know that it is P divides A square, right? So this means that this P is what? Any of this Pi. Whether it may be this P, maybe this P1 or P2 or any P, means any Pi. So therefore, by Fundamental Theorem of Arithmetic, we have this P is equal to any Pi. So this I is from 1 to n, right? It can be P1, P2, P3 and so on. So this means what? P is any Pi and we know that in the previous we have expressed A as a product of P1, P2 and so on. Pn means among this Pi there is one P, right? This means P divides A. Therefore, P divides A. So we have started with P divides A square and now we have P divides A. Therefore, this completes the proof. I hope you got it. We have the proof of root 2 is irrational. So, root 2 is irrational means what? It cannot be expressed as a division of any two integers, right? So for this we will be using contradiction method. Means contradiction method means what? Suppose we will be assuming that root 2 is rational. Okay? Contradiction method means we are going to take in different way, as a different statement and bring it with some contradiction. Okay, so root 2 is rational. So root 2 is rational can be expressed in the form of P upon Q, right? Using the definition. So Q not equal to 0 and we are taking the simplest form of root 2. So simplest form of root 2 means what? HCF of P and Q is 1. Means they don't have any common factor other than 1. Right? Now, after this, let's square it. So, squaring both sides. So, squaring, we have 2 is equal to P square upon Q square. It means what? 2Q square is equal to P square. It means P square can be divided by 2. Right? So, implies P square is divisible by 2 It means by using the previous theorem, we have P is divisible by 2. So P is divisible by 2 means what? We can express P as 2 into some x. X is any number. So we substitute this value of P here. Then we get here 2q square is equal to 2x the whole square. Right? This becomes this. So we have q square is equal to what? 2x square, which implies q square is divisible by 2. So q square is divisible by 2 implies q is divisible by 2. So now we have p divisible by 2, right, and q divisible by 2. It means 2 is the common factor for both p and q, which is the contradiction to what we have here. P and q HCF is 1. Therefore, what we assume that root 2 is rational is wrong. Therefore, root 2 is irrational number. This is the way of contradiction method. Next, we have the next sum. Root 2 minus 5 is irrational number. So for this also, what we will do, we'll assume this as a rational. So when we express this as a rational, we can express this as a upon b, right, as a contradiction. So suppose we have root 2 minus 5 is rational, and we have what it can be expressed as in the form of a by b, right, where b is not equal to 0 and the HCF of a and b is equal to 1, right? So now we can take root 2 is equal to 5 plus a upon b. Now we have 5 as rational, a upon b is also rational here, right, because this is rational, then therefore this is also rational, both are equal. So rational are added, means this side is rational, right? But we know that this side is irrational. Is it possible irrational is equal to rational? Not possible, because this is happening because we have assumed that root 2 minus 5 is rational. Therefore, root 2 minus 5 is irrational number. Okay? In this chapter, we have understood about the real number system, which include the rational number and irrational number. Rational are the number which can be expressed in the form of a by b, where a and b are integer and b cannot be 0, right? And irrational numbers are the opposite of this, which cannot be expressed in the form of a upon b. We have also learned about the fundamental theorem of arithmetic, also the prime factorization method to find the LCM and HCF. Okay, I hope you have thoroughly understood the real number. Keep watching our install video. Thank you.